Hello students and welcome to the lecture 5 of engineering mechanics. In this lecture we are going to discuss Cartesian vectors. By Cartesian we means we are going to deal with the Cartesian coordinate systems which are having x, y and z, all three axes. These axes are mutually perpendicular. What does it mean is that all the three axes are having 90-degree angle with each other. For example, if you look at the x and y, okay, they will have a 90-degree angle, so they are perpendicular. Similarly, if you look at let's say x and z, okay, so you look at x and z, okay, they will also have a 90-degree angle between them, okay. And then similarly y and z also have a 90-degree angle. Similarly, you can see right here they are mutually perpendicular, okay. So that's the second thing. And then because we are using the Cartesian vectors, so you have three axes and each axis have a certain direction, okay, and the direction are represented by this I hat, j hat and k hat. So k with the hat represents the unit vector, okay. And what does the unit vector mean? Unit vector means that it is having a magnitude of 1, okay. So you multiply it with anything, it will not change its value, but it will show that in which direction, either in y, in z or in x direction is that specific magnitude, okay. And previously we talked about 2D, okay. Now we are talking about 3D, so we have x, y and z space. Our vector is usually, we did say that, combination of magnitude and direction. So to represent a vector, either you represent them as bold, okay, you make it bold, or in return we just write it as ax and represent it with the arrow to show that it is a vector, okay, which is actually again a combination of magnitude and direction. So magnitude is shown by this, and then your arrow actually represent that it is a vector quantity. Now you can split these vectors into its magnitude and direction by writing the magnitude. For example, for ax this is the magnitude, and then you write I to show that it is in the direction of x, or it is the magnitude and having a direction of x. Then simply ay in the direction of j, y, okay, and then you have az as the magnitude and it has direction of k which is in z axis, okay. So very simple, straightforward, nothing complicated here. What happens is when you try to um, find out the magnitude of a vector that is in space, okay, so in previous cases we said that our resultant will be equal to square root of rx plus ry, okay. That was in case of 2D. In both cases the squares, okay. So this was a 2D resultant. Now we have a 3D. For example, this is our resultant vector a and it is in space, okay. So what will happen in this case? So let's consider this blue triangle only at the moment. This blue triangle is a combination of two components. One is the a prime and second is this vertical component which is equal to the z component, okay. So we split this vector a in two components. One is a prime, which is actually in the horizontal plane, and one is the vertical component which is equal to z component. So the magnitude of vector a will be given by the a prime square plus the vertical component which is a z square, okay. So this component and then this vertical component, taking the square of that, you get the magnitude of the vector a. Now we see that the a prime, this component, is actually combination of two, the x and y component, okay. So if you look at this vector a prime, it is a combination of this component and also this component. Also keep in mind they are perpendicular, shown here by 90-degree angle, okay. So you can actually write the magnitude of a prime as square root of ax square plus a y square, because it is combination of these two. Okay, and simply if you want to insert this a prime here, so you can just take square on both sides to make it a square. So you take square here and you take square here, so this square cancel out with the square root. You are left with a prime square is equal to ax square plus a y square. So you insert this a prime square right here and you get the vector a magnitude as ax square plus a y square plus a this one az square. Okay, so this will give you the total magnitude of the vector a in the Cartesian coordinates, and that is why we can see that this is the magnitude or the equation for the magnitude of the vector a. Alright, next is find out the cosines. These are the called the cosines of the Cartesian coordinate vector. Okay, which is actually if we know the angles directly with the axis. Okay, so if you know the alpha, which is the angle with the x-axis, you know beta, the angle of the vector a with the y-axis, and you know the gamma, which is the angle with the z-axis. If we know all these, then we can simply find out this cosine by taking cos of those angles. Now why cos? Because the x component in this case is adjacent to the angle, so you can just find out this component using cos of alpha, and cos of alpha would again be ax divided by the total magnitude. Now how does that comes up? Let's see. If we consider these triangles, which is one is blue, one is gray, and one is greenish type. Alright, let's start with this blue triangle, which is the vector a making a triangle with the x-axis. So if you see, this is a 90-degree angle shown right here. Okay, so first start with the origin. So let's draw these triangles one by one. So starting with the blue one, we start with the origin. So let's see, this is the origin, and then you draw this x component right here. Okay, so starting with the origin, you draw the x component. Okay, once we have the x component, then you see this 90-degree angle right here. Okay, so you have a 90-degree angle, which means it will be perpendicular. So perpendicular is directly upward, let's say, or downward. So we have the perpendicular component, and then that makes you a vector a. So that is again from the origin to this point. So again, origin to this point, this makes you the resultant of this vector. Okay, so that is your vector a. This is your ax, which is the horizontal, and then you have this vertical component. Okay, we do not need this at the moment. Okay, so if you want to find out the cos theta, because this angle is given, which is alpha, this is the angle between the vector a and the ax. Okay, just look at it again, the alpha is given here. So you can actually use this triangle to find out the cos of alpha, which is cos is again base by hypotenuse. So this is a base is ax divided by hypotenuse is a. Okay, so you get the cos of alpha. Similarly, if you consider the next triangle, let's say with the y-axis, we will consider this gray triangle, gray or pinkish, whatever color it is, and then starting with the origin. So origin is this one, and you draw a y-axis. Okay, so starting with the origin, okay, you draw a y-axis. Okay, and then you see this is a perpendicular. So perpendicular means having a 90-degree angle. So you draw a perpendicular here. Okay, and finally connecting the origin to the top creates your hypotenuse or vector A. Okay, so you get the vector A, you get this angle beta. This is your y component of the vector A. Okay, so what you get is you can actually use this to calculate the cos of beta, which will be again base by hypotenuse. Base is AY and hypotenuse is A, so you get cos of beta. And finally the third triangle, which is this one. If you consider this triangle, so again start with the origin. You have origin right here, okay, and draw the z component first. Okay, so if you draw the z component first, it would be something like, so you start with the origin, you draw the z component, and then what you see here is a 90-degree angle, so it will be perpendicular to the z component. So perpendicular would be horizontal either in the right or the left direction, whichever you take, and then you join the origin to the end of the vector, so that will give you the vector A. Okay, and what you got is this is your vector A. Then you have this angle given, which is actually gamma, and you have this side as AZ. Okay, and then this you can use to calculate the cos of gamma, which will be base by hypotenuse. Remember, base is always the adjacent to the angle. Okay, so that will be AZ divided by A, so base by hypotenuse. So you got these three equations as the cosines of these triangles, and that is what we have right here. So cos of alpha, cos of beta, and cos of gamma. I hope it is clear enough at this stage, because it's very important to solve the problems ahead. Okay, and then you can actually divide this vector by the total magnitude. So if you divide it by the total magnitude of the vector, which is actually calculated here, you will get the unit vector of the vector A. Unit vector is actually a vector in the direction of A that has a magnitude of 1. Okay, so that is very simple, and you see that these quantities, after dividing by the whole vector, after dividing this whole vector by the magnitude of the vector, you see these components, these comes up to be your cosines. Okay, so you see this is ax divided by a, and then you have ay divided by a, and then you have az divided by a. So these are actually cosines, and you can represent them with the cosines. If you have an angles, you can just get the unit vector using those cosines. All right, so let's solve the very basic problem using the Cartesian vectors that we just learned. And it says that show how to resolve each force into x, y, and z components. Set up the calculations used to find out the magnitude of each component. Okay, because your angle with the z component is directly given, which is 45 degree, so you can simply find out the fz or the z component by using the cos theta. Angle is directly given, so it will actually give you the z component of this vector. So that will be f cos of 45. Okay, and f is 600, cos 45, it will be 600 cos 45. That is 424.26. Okay, So that is your z component. You got one component now. Very simple, straightforward. This is the magnitude of this component z. What about x and y? So to know the x and y, we do not have the angle directly given with the x and y. If it was that given, then we can simply use the cos of that. But in this case, we do not know the angles directly with x and y. So what we will do is we will actually calculate this angle, okay, and find out this f prime component. So let's call this as f prime, okay, which is actually this component from the origin to this point. Okay, so if we can calculate this component, okay, and the angle given for this one, let's call it as alpha. Okay, so that is alpha is in this case equal to, because the total from this point to this point is 90. Okay, so alpha will be 90 minus 45, taking this one out, so you will be left with alpha, which will be equal to 45. 90 minus 45 is 45. Okay, so now we know the angle of f 600. We know the angle of f with the f prime. Okay, so f prime will be actually the horizontal component or the horizontal component of the f. So you can simply get the f prime as, if you consider this triangle, so you have the one side as this, second side as this, and third side as f prime. Okay, so if you consider this triangle, you know the angle alpha now, so you can simply calculate the f prime equal to f cos of alpha. Alpha in this case we calculated is 45 degree. So simply it is the same thing as it was here, f cos of 45, so the value will be the same. F prime will be equal to, if you do the calculation, so that would be 600 cos of 45, which is again equal to 425.26. that is your f prime. Now comes the second step. Now we know the angle 20 with the y. That would mean that your f y will be equal to, now the angle of f prime, this is f prime, which is this one, with the y is 20, so you can use that. So f prime cos of 20, cos because the angle with y is given. Okay, and f prime is your 425.26 cos of 20. Now fy will be equal to 425.26, and you can simply multiply it with the cos of 20. So it is 398.677. 398.677. Okay, this is the magnitude of your y component. Okay, and then you can get the magnitude of the z x component. It will be f prime sine of 20 degree. So f prime is 425.26 and then sine of 20. Okay, four 25.26 sine 20, 145.44. Okay, now we got the x component as well. So we have the x component, we have the y component, and we also have the z component. Okay, so you have your z component is right here, your y component and your x component. Now we can actually represent them in the form of vector as well. So your f will be equal to your fx I plus fy j plus f z k. That is what we said, how the vectors are represented. So using this way you can actually represent the force F equal to, because our Fx is 145.44, you can simply write I with it, plus Fy is 398.677, and then write J with it to represent it in the Y direction, and then finally your Z component is 425.26, and it is in the K axis, so you have the final vector representing the magnitudes of each component and also having the directions of each component. Okay, so this is a very simple problem. I hope it is clear enough, where we saw how the components were calculated and we also saw the magnitude of each component. Okay, and the direction shows which component they are. I hope it is clear enough. If you have any questions, please put them in the comments and I would be happy to entertain that. Thank you very much. Take care. Goodbye.